Right, in this test we're looking at your progress on dealing with data and probability questions, and most of the sort of data and probability questions are grade C questions. The only topic really in this paper that would be considered to be a grade B question would be Venn diagrams. So those two bonus questions then in this case are questions 10 and 11. If you get your head around those, that really is a bonus, because they aren't that difficult to learn how to deal with. But pretty much everything else on this paper you should be aiming to score marks on if you're aiming to get that grade C. So let's see how these pan out. Okay, question 1. Pupils have a choice of a sandwich and a drink for lunch on a school trip. They can choose a ham, cheese or salad sandwich, and to drink water, milk or orange juice. Write down all the possible combinations of a sandwich and drink that a pupil may have for lunch on the school trip. Now, the most important thing to be with questions like this is systematic in how you work things out, so or how you set things out. So you could be a bit scatterbrained and say, well, they could have a ham and water, or they could have a cheese or milk and a salad or water, and in doing it that way you're highly likely to leave things out. If you're systematic, and you'll see what I mean by that as I go through it, then you're far more likely to score the marks. So what you do is you pick one of the first choices, ham, and then you keep that the same and consider all the possible drinks they could have. So they could have ham and water, or they could have ham and milk, or they could have ham and orange juice. So with regards to having a ham sandwich, those are all the possible outcomes they could have. So once we've exhausted ham sandwich, we then move on to cheese sandwich. So they could have cheese with water, cheese with milk, and cheese with orange juice. So again, I know I've exhausted that list, and I got the same number for cheese sandwich as I have for ham sandwich, so I'm feeling pretty good that I'm doing the right thing here. And then once I've exhausted cheese, I go back to the next choice of sandwich, which is salad, and then vary the drink. So I could have salad water, I could have salad milk, or I could have salad orange juice. And those then are all the possible outcomes. There are no other sandwiches, and for each of the sandwich choices I know that I've considered every possible drink. Part B. What is the probability that a pupil selects a meat-free sandwich with an orange juice drink? So again, a question like this, they'll often ask you to list all the possible outcomes and then use it to work out a probability. So what you need to do is consider how many ways you could have a meat-free sandwich with an orange juice drink. Well, the meat-free sandwiches are cheese or salad, so you could have cheese and an orange juice, or you could have salad and orange juice, meaning that there are two possible ways you could have that meat-free orange juice combination, and then for the probability you write that as a fraction out of all the possible combinations there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability is 2 out of 9. And you leave it like that. And it's important you write it as a fraction. You don't write 2 in 9. Okay, so that's that first one. Question 2. A fair coin and a fair-sided dice are thrown together. Calculate the probability of obtaining a head and a 2. Now that's a more difficult question because they haven't set it up for you by asking you to list all the possible combinations first. So you have to realise that that's what you need to do. So we've got a fair coin and a six-sided dice. So the numbers that we could have on a six-sided dice, we could have a 1. And that 1 could end up with a head on the coin, or it could end up with a tail on the coin. So I've exhausted all the possible arrangements there are with the 1 on the dice. So now I'm going to do the same for a 2 on the dice. Could be a 2 and a head or a 2 and a tail. 3 head, 3 tail. 4 head, 4 tail. 5 head, 5 tail. 6 head, 6 tail. And that's it. There are no other arrangements that could come from that combination of throwing a coin and a dice at the same time. So the probability of obtaining a head and a 2, well, there's only one possible outcome, which is going to be a head or a 2, a head and a 2, but it's out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes. So the probability is 1 out of 12 written as a fraction. Okay, so again, just like the first question, it's important that you're systematic in how you are writing your or listing your possible outcomes. Question 3. Mr. and Mrs. Khan are beginning to think about their holiday plans for next year. So far, they've decided that the holiday will be in May, the holiday will be in May or September. It will be in the UK or in Ireland. It will be a single location holiday or a touring holiday. Complete the table below to show all the possible combinations they might finally choose. One of the possible combinations has been given to you. So it could be May in the UK and a single location. And just like with the previous questions, we're systematic in what we do here. We keep these fixed and change that one until we've exhausted those. So it could be in May, UK, single, but it could be May, UK, touring. Now, as far as May in the UK is concerned, there's no other choices. But they could be going to Ireland in May. So we keep the month of May until we exhaust it. And they could be going to Ireland. And in Ireland, they could be staying in a single location, or they could be touring. So that's exhausted Ireland in May. And what we've done now is we've exhausted all the May possibilities, because in May you're either going to go to the UK or Ireland, either single or touring. If they're not going in May, then they're going in September. If they go in September, they could be going to the UK and it could be single. They could be going in September, UK, touring. So again, I've fixed these and I've exhausted those. Now this is exhausted. It just leaves me Ireland in September, and that's either going to be single or it's going to be touring. And we can see here there were 4 possible in May, so we should expect 4 in September, and we can see there that that has been systematically laid out like that. Okay, so those were all to do with listing outcomes. Question 4. In a game of Dungeons and Dragons, a fair 12-sided dice is rolled. What is the probability that a prime number is shown on the dice. So with this one, it's mixing your knowledge of probability with knowing what a prime number is. So on a 12-sided dice, those are all the possible numbers that could come up. Now, as far as the prime numbers are concerned, 2 is the first prime number, 3 is a prime number, 5 is, 7 is, and then you have to be careful because then you think, oh, all odd numbers are, and that's not the case. 9 isn't a prime number because 3 divides into it. 11 is the next prime number. So the chances of you rolling a prime number on a 12-sided dice is 1, 2, 3, 4, 5 out of 12 because it's a 12-sided dice. So looking along there, we can see that that is our probability. 280 raffle tickets were sold at a fete. Sian has a 15% chance of winning the top prize. How many tickets did Sian buy? So generally, probabilities are given as fractions, but they can also be written as percentages or decimals, as we'll see later on. So all we need to do here is work out what 15% of 280 is. So non-calculator paper. So if we first of all work out what 10% is by dividing by 10, knocking off the naught, 28. 5% in that case will be half as much, which is 14. So to work out 15, I would add those two together, 10% and 5%. So if I add these together, 8 and 4 is 12, 2, 3, 4. I would need to buy 42 tickets. Part C. A bag contains a mixture of blue, yellow and pink beads. One bead is taken at random from the bag. The probability that the bead is blue is 2/5. Which of the following sets of beads could have been in the bag? Circle your answers, plural. So if we work out for each of these what the probability of drawing a blue bead out is going to be. So in this one, there is 6 blue out of 12, 15. With this one, 5 blue out of 15. This one, 1 out of 7. This one, 5 out of 11. And this one, 6 out of 15. Now none of those is written 2/5. So what we have to do now is look to see if we can simplify any of those fractions. I can see here that 6 and 15 both have 3 as a factor, so I can divide them both by 3. 6 divided by 3 is 2. 15 divided by 3 is 5. These two numbers, 5 is a common factor, so I can divide both by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. I can't simplify that one. I can't simplify that one. And these two fractions are the same. So there are 2 bags there where the probability of getting a blue is 2/5, which is this one and that one. Question 5. Nia has made up a game using 2 fair spinners. The faces of the spinners are shown below. The first spinner is an equilateral triangle with sections numbered 1, 3 and 5. The second is a square with sections numbered 2, 4, 6 and 8. Nia spins the triangular spinner first and then she spins the square spinner. Her score is a 2-digit number. The first digit is the number on the triangular spinner and the second digit is the number on the square spinner. Nia writes down all the possible scores she could obtain. Some are done for you. Complete the list of all possible 2-digit numbers that she could get. So from that, what you need to lift out is the fact that That's going to be the tens number. That's going to be the units number. So that's currently looking at 32. So you'd write it as 32. Again, what we want to be here is systematic. So what this row is giving us is, if that's stuck on 1, then it could be 1 followed by 2, 1, 4, 1, 6, 1, 8. So we're now going to go 3, 2, 3, 4, 3, 6, 3, 8. Then we've exhausted that one, so the next possible outcomes are if there's a 5 on the triangular spinner, followed by a 2, 4, 6, 8. Then we know we've exhausted all the possible outcomes of that combination of spinners. Write down the probability that Nia gets a score that is greater than 37. So greater than 37 is that one, that one, that one, that one, and that one. Those are the only numbers that are larger than 37. So the probability will be 1, 2, 3, 4, 5 out of all the possible outcomes she could get. And it's a common mistake here is to forget to include the ones that were given to you. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes, 5 of which would give you a score greater than 37. Write down the probability that Nia gets a score that is less than 70. Well, all the numbers are less than 70, so you could either write that as 12 out of 12, or 1, or 100%, because she's definitely, it is certain that she's going to get a score less than 70. If the question had said more than 70, the answer would have been 0. Impossible. Nia says that she will always get even numbers for her results. Is she correct? You must give a reason for your answer. Well, if you look at your results there, you can see they're always even, and they're always even because they end in a 2, 4, 6 or 8, which means they'll always divide by 2. So I said yes, she is correct. The numbers can only end in 2, 4, 6 or 8, which will make them divisible by 2. And any even number is divisible by 2. Question 6, more spinners. The 2 spinners are spun. The score is the total of the 2 numbers shown on the spinners. The score shown above is 8. So 5 and 3 is 8. There are 2 different game cards, card A and card B. The game is played crossing out the scores from the spinners on the game card as the spinners are spun repeatedly. So like a game of bingo, they cross those out. The first game card with all 4 scores crossed out is the winning card. Which game is more likely to be the winning card? You must show working and give a reason for your answer. Okay, so this is quite a difficult question because you have to make a big decision at the start. And the big decision is you can't tell which of those is more likely until you know what scores are possible and what scores happen more than any other. So the best way of doing that is by drawing your own sample space diagram. And what they will look like for this is, if I do it, where should I put it? Put it down here. So 1, 2, 3, 4, 5. So that's the possible outcomes for one card. 1, 2, 3, 4, 5. Sorry, one spinner. And the totals are added together. So if that spinner has got a 1 on it and that spinner's got a 1 on it, the total is 2. If the first spinner is a 1 and the second one is a 2, the total is 3. 3 and 1, 4, 5, 6. 2, so we've changed now. First spinner's on 2, the second spinner's on 1, 3, 4, 5, 6, 7. Now the first spinner's on 3, second spinner's back on 1, 3 and 1 is 4, 5, 6, 7, 8. 4 and 1, 5, 6, 7, 8, 9. 5 and 1, 6, 7, 8, 9, 10. So inside that diagram now you have all the possible scores from playing this game. And what we want to do now is to see what the chances are of getting a 2, a 3, a 9 and a 10. So 2, 3, 9 and 10. So in order for the card A to win, they've got 6 possible outcomes that will help them win. So 6 out of 5 by 5, 25. So every time the game is played 25 times, there's only 6 chances of those numbers coming up. Whereas 4, 5, 6 and 7, I just change my colour. 4, 5, 6 and 7 have got many more times, many more chances of those scores coming up than the other. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 out of 25. So when it's set out like that, it's much easier to see which one is most likely to win. So we can now say game B is most likely to win, as there are more chances of these numbers coming up as the game is played. It's important the examiner can see that you have made those comparisons, 6 out of 25 compared to 16 out of 25. And you wouldn't get those unless you've made the decision to draw that table, which they're not asking you to do. And that's what makes that quite difficult. So question 7 is a similar question to the previous one, but this time they're giving you a whopping great clue. There are 4 balls numbered 1, 3, 5 and 7 respectively in machine A. Machine A, 1, 3, 5, 7. And 4 balls numbered 2, 4, 6, 8 in machine B. In a game, both machines select one ball at random. The score for the game is the product. So you need to know what that means, ideally, but if not, it does give you then a clue. For example, if the number on the ball from machine A is 3 and the number from machine B is 4, the score is 3 times 4, so the product means times, which is 12. Complete the following table to show all the possible scores. So pick a number first of all and make sure you're happy with where it comes from. So 3, 4, 3 on machine A, 4 on machine B, 3 4s are 12. So if it's 3 on machine A, 6 on machine B, 3 6s are 18. 3 8s are 24. 5 6s are 30. 5 8s are 40. 7 6s are 42, 7 eighths are 56. A player wins a prize by getting a score of 12 or less. It costs 80p to play the game once. The prize for winning the game is £1.50. If 160 people play the game once, find the expected profit. So, in order to win the game, you've got to score 12 or less. So what are the chances, what's the probability of you scoring 12 or less? I've just put circles around all the numbers that are 12 or less, and there are 1, 2, 3, 4, 5, 6, 7. So the probability of winning will be, did I say 7 out of the total possible number of outcomes, which will be, in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So out of every 16 times that game is played, 7 are likely to win. If 160 people play the game once, find the expected profit. So the number of winners when 160 play the game will be 7 in every 16 lots of 160. So what you're doing is seeing how many groups of 16 there are in 160, and hopefully you can see there are 10 of them. So that's going to be 7 winners in every group of 10. So we're going to have 70 winners. Everybody, so 70 winners, and they're each going to get £1.50. So amount paid out to winners will be £1.50 times 70. So that's £70 if it was £1, plus half as much again, which is another £35. So that's going to be 70 plus 35, £105. So the person who's running this game is going to expect to have to pay £105 out. But everybody that plays the game has to pay 80p. So the amount paid in to the game is 160 lots of 80. Well, if we just, it's a non-calculator paper, so we've got to do this using a non-calculator method. So 6 eighths, 48, 1 8 is 8, that's 128, followed by 2 zeros, pence, which is 128 pounds. Expected profit. The game owner is going to be paid £128 by the players, and is going to have to give out 105 to the winners. So the profit will be 128 less 105, which will be £23 profit. Now, that's a grade C question, because you've got to make those decisions and stages and steps yourself. But if you can practice that, and if you go to the Jones & Son website, there are lots of questions on games of chance, those are called, and practice those, then those are easy marks to gain. Question 8. In a game, so we're still on games of chance, a player rolls a coin onto a squared board. The squares on the board are coloured red, blue, green or yellow. If the coin lands entirely within one of these coloured squares, the player wins the prize. Otherwise, the player loses. The table below shows the probabilities of a coin lying entirely within the coloured squares. So there's a 0.15, so now we're working with probabilities in decimal. We've met percentages, we've met fractions, now we're in decimals. So there's a 0.15 chance of winning on a red, a 0.09 chance on a blue, 0.05 on a green, 0.06 on a yellow, and there's a 0.65 chance that the player loses. One day, 200 people play this game. Approximately how many would you expect to win? Well, we know that they've got to all add up to 1, because that's your total probability. So the probability of winning, you could add up those, or you could just take 0.65 away from 1. So probability of winning will be 1 minus 0.65, which is 0.35, or add them up and you should get the same thing. So the chances of one person winning is 0.35. So for 200 people, we're going to be doing 200 lots of 0.35, or 200 lots of 0.35. If I multiply that by 100, that's the same as 2 lots of 35, which is 70 people. Okay, so whatever method you've got for doing that without a calculator, if it's a different one to mine, that's fine. It costs 80p to play the game once. The prize for winning is £2. So if 200 people play, so we've done that. Approximately how much profit would you expect the game to make? So 70 winners, each getting £2. So pay out to winners will be 2 lots of 70. £2 times 70 winners is £140. But each of the 200 people have to pay 80p. So paid in to game will be 200 lots of 80p, which is going to be 16 followed by 1, 2, 3 zeros pence, which will be £160. So how much profit do we expect to make? Well, there's £160 paid to play the game. He's got to give out £140 in winnings, so the profit is £20. Hopefully now you're starting to see a pattern with that. Again, Jones and Sums, intermediate tier, games of chance. Practice those, it's really worth it. Question 9. Thomas has one spin of the circular spinner shown below. 2 of the lines shown on the diagram are diameters of the circle. So diameters go right the way through the center of the circle. So we have that line there, which is the diameter, and that line there, which is the diameter. That means that that angle there and that angle there are equal, which means that the area of that red and the area of that green are the same. So the chances of you landing on red or green are going to be the same. Table below shows the probabilities of Thomas obtaining yellow, white and green with one spin of the spinner. Complete the table. So because we know those are diameters, so the angles opposite on intersecting lines are the same. Red and green are the same. So if green is 0.18, red is 0.18 as well. I know they've all got to add up to 1. So whatever the difference is between 1 and the sum of those will give me blue. Or alternatively, I know that red and blue cover half the spinner, so that those two must add up to 0.5. So if I take that away from 0.5, that's another way of arriving at the chances of blue. Whichever way you do it is up to you. So we got 0.12 and 0.18. That comes to 0.3. And 0.2 is 0.5. And that is 0.68. So 1 less 0.68, £1 less 68 pence, 32 pence. So that's 0.32. Again, whatever method you want to use to take those away from 1 is up to you. The most important thing is you recognizing that red and green must have the same chance. Find the probability of obtaining either white or green on the spinner. Well, white or green, you're going to add those together. .3. That's C grade. The last part of this is a B grade bit, which is if you need to know that if you are going to be saying both obtain yellow, so yellow and yellow, if you're using the word and, you have to multiply the probabilities. If you're using the word or, you add the probabilities. So Sasha has an identical spinner. Thomas and Sasha each spin their spinners once. What is the probability they both obtain yellow? So yellow for the first one and yellow for the second one. Back to you now as far as how you know how to multiply two decimal numbers without a calculator. 2 2s are 4. There are two numbers after the decimal point, which means there need to be two numbers after the decimal point in your answer. So 0.04. So that bit's grade B. And then we're on to the final two questions, which are also grade B on Venn diagrams. So let's have a look. There are 80 students in year 11. 9 students study French and German. 35 only study French. 2 do not study French or German. Complete the Venn diagram. So all the numbers that we put inside that rectangle have to add up to 80. 9 study French and German. The French and German is the overlap. So if you're in there, you're in the circle for German and the circle for French. So you're what's called the intersection. They do both. 35 students only study French. So the only study French bit is in the French circle, but not in the overlap. So the 35 goes there. 2 do not study French or German. So they're in the rectangle, but not inside the circles. So those 2 go there. Complete the Venn diagram. So the bit that's missing is we don't know how many only do German, but we do know that these numbers have to add up to the total for the year group, which is 80. So there we've got 44 plus 2 is 46. So 46 pupils are accounted for out of the 80. So 34 aren't anywhere, so it must be 34 that do German only. Those numbers now add up to 80 and everybody's in the right place. So the answer to the second bit, work out how many study only German. The answer is 34. And the final question. In a class of 24 students, 12 play the piano, 12 play the guitar, 4 play neither. Okay, so I need, just like the one above, 2 circles in there, one for piano, one for guitar. 12 play the piano, 13 play the guitar, 4 play neither. So I know that I've got 4 out there, and I know that everything must add up to 24. So in here I've got 24 less 4, that's got to come to 20 students, but I don't know how many play both. So what you have to do here is I'm going to do a bit of algebra, unfortunately. I don't know how many are in that overlap, but I do know that there are 12 piano players. So the total circle has to come to 12. So piano only is going to be 12 less however many are in that circle, are in the overlap. And similarly for the guitar, there's 13 play the guitar, so only playing the guitar is 30 less the numbers in the overlap. So piano, if you add up piano, it's going to be 12, take x, add x, the x's cancel, leaving you the 12. For the guitar, 13 plus x minus x leaves me 13. Now I know that that plus that plus that come to 20 because the 4 are there that aren't doing it. So I know that 12 minus x plus 13 minus x comes to 20. Right, 12 plus 13 is 25. Minus x plus x, 0. So I've still got that minus x there, is 20. So 25 minus something is 20. What's the something? 5. 25 minus 5 is 20. So I now know that x, my intersection, the number of kids doing both, is 5. So that's 5. This is going to be 12 less 5, which is 7. And this is going to be 13 less 5, which is 8. So again, grade B stuff, more complicated. Work out the probability that the student only plays the guitar. Well, we've done that now. The number of students that only play the guitar is 8 out of all the students, which is 24. Now you can cancel that down, but you may get it wrong. So it doesn't ask you to give the fraction in its simplest form, so you're better off leaving it as it is and not making that mistake. So Venn diagrams, a bit more complicated to get your head around, but certainly you should be able to get some marks on those.